All right. So up until now, we've been dealing with atoms that have been neutral, and atoms that are neutral are atoms that have equal number of protons and electrons. And so we are going to talk today about atoms that have gained or lost electrons, and when they do that, they are called ions. Atoms have a tendency to gain electrons or lose electrons to become charged atoms that we call ions, and they do that, atoms gain or lose electrons, so that they can have a more stable arrangement of electrons. And we'll spend a great deal of time discussing that in the future. But for now, you just need to know that the entire point and purpose behind an atom gaining or losing an electron is so that that particular atom can have a more stable arrangement of electrons. Which brings me up to this. How does this make you feel? Sad? Oh, that was not the answer I was looking for. Oh. A lot of people are like, they get that little smile and they're like, oh, kitties. And you're like, oh, kitties. And the reason why I bring this up is, yes, these are the cats that reside in my residence, or more likely, these are the cats that let me live at my residence. But here's the thing. And I'd like to point this out really quick here. Do you see this monster cat right here in the middle? This monster cat right here in the middle. That particular cat right there has, look at his, it looks like his paw is deformed, doesn't it?
Oh, it looks like it's like 2 paws.
Yeah, he has 7 digits on that particular paw.
Wait, what?
7 fingers on that particular paw. Pardon?
Oh, no, that's your cat.
That's one of our cats. That cat is named Seamus Finnegan, but he's such a fat, lazy cat that we just call him Schmoopy.
But how old is he?
No. My wife got him and thought that he was a good Irish orange-haired cat, and she is Irish, and so she named him a good, solid Irish name, and he was feisty, and she thought he was a fighter, so she called him Seamus Finnegan, the boxer in her head. The one on the left is my cat, Squirrels, also known as Squirrely Dan. And the one that's really derpy on the right-hand side is Bean. Now, the reason why I show you 3 pictures of cats is simply because cations are positive. Cations are positive. So that little deep dive into what happens at my house had everything to do, was a setup for this particular side. So cations are positive, which means that atoms that lose electrons become positively charged. Okay. Now let's talk about what that actually means. The atom of calcium, when it's neutral, so calcium, when it's neutral, has, it would have 20 protons, it's going to have 20 neutrons, and it's going to have 20 electrons. If, and according to the information up above, it does, if it loses 2 electrons, it becomes an ion. Well, I'm going to be even more specific, a cation that will have 20 protons, 20 neutrons, and 18 electrons. Now, we need to do some very complicated math right here to get to the bottom of this. So 20 positive things plus 20 negative things is equal to 0, right? And 20 positive things plus 18 negative things is equal to plus 2. So that means that when calcium forms an ion, it becomes calcium with a plus 2 charge. and it's simply named the calcium ion. Now, the next example that we have is aluminum. So when aluminum is neutral, aluminum will have 13 protons. It will have 14 neutrons, and it will have 13 electrons. When, according to the information above, aluminum loses 3 electrons, it becomes a cation. So aluminum will have 13 protons, 14 neutrons, and 10 electrons. If we do some supporting math here, 13 positive things plus 13 negative things is equal to 0.
Yeah.
And 13 positive things plus 10 negative things is equal to plus 3. So that means that the aluminum atom, when it becomes an ion, becomes a aluminum plus 3 ion. So those are cations. They lose electrons to become positively charged. I don't have a fun picture for anions because they're just the opposite of cations. If cations are positively charged, anions are negatively charged. So when an atom gains an electron, it becomes negatively charged.
Can't you get the 2 extra fingers on your cat remover?
How did it, what?
Can't you get the 2 extra fingers on your cat remover?
Well, if you had extra fingers on your hand, would you want your mom to remove them?
Yeah.
Oh. No, it just...
Well, like a doctor to remove them.
No, I mean, I guess, but like, I guess you could, but it just seems like, don't get me wrong, I love my cats, but it feels like a lot of money for a surgery that's really kind of unnecessary. It doesn't bother them.
Yeah, that's true.
Yes, sir.
You ever seen Gravity Falls, like a show?
Yes.
You know that dude with 6 fingers?
Yes.
I know he got bullied in school.
Yes.
That's why you don't want to have him body.
Fair.
You're gonna get bullied.
But what if that guy?
Life, I mean, nothing against animals,
But what if you learned to use that 6 finger and you could play the piano or the guitar so well that you became a virtuoso?
What if it's just there, like, it doesn't do anything?
Gloves. You can't wear gloves.
Anyway, anions. What about gloves? Mittens, right? Anyway, with a neutral atom of fluorine, we would have 9 protons, 10 neutrons, and 9 electrons. And if fluorine gains 1 electron, it will become an anion. And that anion will still have 9 protons, 10 neutrons, but now it's going to have 10 electrons. And if we do the fun, simple math, right? 9 positive things plus 9 negative things is 0. And 9 positive things plus 10 negative things is minus 1. So that means that the anion fluorine becomes F minus 1. Technically, it's called the fluoride ion, which is something we'll spend a lot of time talking about probably in the second semester.
Wait, I kind of like blanked out. So wait, you did this in the cations too. Where did you get the 10?
I'm telling you that a fluorine will gain an electron. And so that's where I got the 10.
So it's not always going to be 10.
Atoms are going to gain very specific electrons. So the answer to that question is it'll always be 10, but it's going to be different for each element. Don't worry, that part won't be too hard. Okay. Now, oxygen, neutral oxygen. Let's see. Neutral oxygen will have 8 protons, 8 neutrons, 8 electrons. When neutral oxygen gains 2 electrons, it becomes an anion. And that anion would have 8 protons, 8 neutrons, but 10 electrons. So if we do the fun math, 8 positive things plus 8 negative things is 0. And 8 positive things plus 10 negative things is minus 2. So that means that the oxygen atom will become oxygen with a minus 2 charge when it becomes an anion. Now, for the scope of this class, for the scope of this unit, we are going to use our new knowledge of ions as it relates to the electron configuration for an individual atom. So I'm going to bring up this fancy dancy periodic table right here, and I'm going to mark it up very similarly to what you guys should have for your periodic table. So while you're getting out your periodic table, I'm going to mark up this one. And while I'm doing that, I'm just going to, highlight some stuff, I guess, or square out, box out some stuff here. So this blue area is the S block, for those of you that might remember. The red area over here that I'm making a box around is going to be my P block. Hopefully that is not new news to you. The yellow area that I'm making a box around down here is going to be the D block. And then I'm gonna make, like, I don't know what best color to use here. I'm gonna renumber these to be 3, 4, 5, and 6. Maybe that'll be something that'll be helpful later on. Now, so what I want to show you though is this. We are going to talk about the electron configuration for about 6 different atoms as they become ions. Now, one of the things that I want to start with is the electron configuration when the atom is neutral. So with oxygen, and I'm going to go back up here, oxygen is right up there in the periodic table. It's in the P block. It's in the 4th column of the P block, right? So if I go to write the electron configuration for oxygen, I would write 1s2, 2s2, and then, 2, and then 2p4. Okay. Now, the problem here doesn't ask you to do this, but I'm going to do it in an effort to show you, I think. So I'm going to write the orbital notation for oxygen up on top. Real quick once. And then I'm going to do 2, 2. Oh, that's not what I wanted. That's not what I wanted, Mr. V. Okay, so here we go. Arrow up, arrow down, arrow up, arrow down, arrow up, arrow up, arrow up, arrow down. Now, in this example right here, hopefully what you can see is that the P sublevel doesn't have 6 electrons in it. The P sublevel can have a total of 6. So if oxygen right now only has 4 electrons in the P sublevel and it happens to gain 2 electrons, those 2 electrons are going to go one here and one there. Does that make sense? So when I write the electron configuration for the oxygen ion, it's going to be 1s2, 2s2, correct, 2s2, and then it's going to become 2p6. When an atom is got a negative charge as an ion, it has gained electrons. Okay?
When positive, it gets rid of it.
Correct. Now, what I want to show you, though, and I'm not expecting anybody to remember this off the top of their head, but looking at the periodic table, which element on the periodic table happens to have an electron configuration of 1s2, 2s2, 2p6? Yes, neon. So in reality, you could potentially write neon. Now, what type of an ion is this? Is this a cation or an anion? Positive or negative? It's negative, so it's going to be anion. Okay. Now, the next element that we're going to take a look at is magnesium. And I'm going to go and shade in magnesium up here. So magnesium is in the third period. I think I can write the noble gas shortcut for magnesium. So which noble gas would I use to write the noble gas shortcut for magnesium? Neon, right? Because it's the one in the row above. So I'm going to write neon. And then because neon is in the third energy level, or because magnesium is in the third energy level, it's going to become 3s2. Now, in this case, I see that in the ion part or ion column, it's going to become magnesium plus 2, which means it's going to have lost 2 electrons. And if it loses 2 electrons, what will I be able to write for its electron configuration as an ion?
Neon.
Just neon.
That's crazy.
And in that instance, is it an anion or a cation?
Cation.
It is a cation. All right. Now, aluminum is right here. Okay. It's in the P block. It's in the first column of the P block. I could probably use a noble gas for this one, for the shortcut. Which noble gas would I use for the shortcut here?
Neon again?
Neon again. There's a distinct purpose. So I'm going to write neon. I'm then going to write 3s2. And then I'm going to write 3p1. So if aluminum is a plus 3, that would mean that it's going to lose 3 electrons. And so if it loses 3 electrons, it's going to lose 1 from the P and 2 from the S, and it will simply become neon, which is a cation. Now I want to go back up here and I want to show you something, because there is a reason why I chose those 3 atoms to do right now. If I look at aluminum and it loses 1 electron, it loses 2 electrons, and it loses 3 electrons, it becomes an electron configuration like neon. And if I look at magnesium and it loses 1 electron and 2 electrons, it becomes an electron configuration like neon. And if I look at oxygen and it gains 1 electron, 2 electrons, it becomes an electron configuration like neon. Yesterday, when I talked about the noble gases, I said the noble gases were inert elements, meaning that they don't react with stuff. So when atoms don't react with stuff, it means that they have a very stable arrangement of electrons. So oxygen, aluminum, and magnesium all either gained or lost electrons to have a more stable arrangement of electrons around the nucleus of the atom. Does that kind of make sense?
Mm-hmm.
Wonderful.
Yeah.
Now we're going to talk about some elements in the D block. We're going to talk about elements like zinc, which is way up here. I see that zinc is in the D block. It is in the third period, or it is in the 10th column of the D block. So, so I got ahead of myself. So we would use the noble gas argon for zinc, right? So I'm going to go argon. And because zinc is in the D block and argon is in the third energy level, after argon would be 4s2. And then we would have 3d, and because it's all 10 columns of it's all across all 10 columns of the D block, it's going to be 3d10. Now, zinc has a +2 charge, which means it's going to gain or lose electrons. It is going to lose 2 electrons. Now, here's the most critical and important part about this section of the lesson today. Electrons are always lost from the outermost energy level. So in zinc, based on what I've written here, which energy level is the biggest? 4. So that means that the 2 electrons that zinc is going to lose are going to come from the 4th energy level. So this is going to lose 2 electrons from 4s2. So when I write the electron configuration, it's going to be argon 3d10. Because it lost 2 electrons.
I don't know why I was thinking 4th. I saw 4th.
Oh, 4, yeah. All right. So when you check for the largest number of valence electrons, you always look for the outermost energy level. And so when they lose electrons, they always lose from the outermost energy level first. So in that case, we lost from the 4 instead of the 3. Which brings me to zirconium. Zirconium is here. Okay. Which noble gas would we use to write the shortcut for zirconium? It's 40. Krypton it is. So we would use krypton. And krypton is in the 4th energy level. So after the 4th energy level, we would have 5s2.
Was krypton 36 or 38?
36. And then we would go into 4. D and zinc, zirconium is in the second column, so it's going to be a 42. And if electrons are always lost from the outermost energy level, and it looks like zirconium here is a +1, so that means it's going to lose 1 electron from where?
5s.
From 5s. So that means that when I rewrite this, it's going to be krypton 5s1 and 42. Okay. Now, cobalt. Let's find cobalt on the periodic table. Cobalt is there. It's element number 27. So we would use argon as its noble gas. And argon ends 3p6 in the 3rd energy level. So we're going to go 4s2. And then we are going to go, cobalt is 1, 2, 3, 4, 5, 6, 7. So it's going to be 3d7. Now, it says it's going to be cobalt plus 3, so that means it's going to gain or lose electrons.
Oh, lose.
It'll lose 3 electrons, 2 from 4s2, and 1 from 3d6. So when I rewrite this, it's going to be argon 3d6. So does that make a little bit of sense? Bless you. Now, you may remember from earlier this unit, we talked about something called the photoelectric effect. And in the photoelectric effect, what we discussed was the fact that if you shined a beam of light on a piece of metal, and the beam of light was of a high enough intensity that it had enough energy, it could eject an electron from the metal to a higher energy level. We said that before the light was shined on it, the metal was in its ground state, and when the electron was ejected, the metal was in its excited state. So now we're going to talk about what that looks like in terms of electron configurations. So hydrogen has 1 electron to start with, and its electron configuration would simply be 1s1. If we put that 1 electron in the excited state, it would become like 4s1. We just had the electron jump from the first energy level to the 4th energy level. Sodium's electron configuration in the ground state is 1s2, 2s2, 2p6, 3s1. In its excited state, an electron from the 2p6 jumps up to the 3s1, and that now becomes 1s2, 2s2, 2p5, 3s2. So in its excited state, the number of electrons is still the same. We just had one move to a different energy level. In zinc, ground state is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. And in this case, we had one of the electrons jump up to the 4p1. And so that became the excited state. So your job in this particular section of the notes or of the homework or of the quiz or whatever is to simply look at an element's electron configuration and determine whether or not that element is in its excited state or not. So to practice that, I have an electron configuration 1s2, 2s2, 2p3, 3s1. Okay? And so in this instance, it is plausible that the 1 electron in the 3s1 could probably be in the 2p3. So I'm going to say that this is excited state. And I'm going to put an explanation because the electron in the 3s1 could be in the 2p3. So it could be 2p4. Now, how do I use this to identify the type of element? Well, if I add up the electrons that are present, 2 plus 2 plus 3 plus 1, 2 plus 2 is 4, plus 3 is 7, plus 1 is 8. The element on the periodic table that has 8 electrons is oxygen. And you might think of it as 1s2, 2s2, 2p4. So this element is in its excited state because one of the electrons is where it doesn't belong. If I look at the next one, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, to me it looks like all of the electrons and the energy levels and the orbitals are all in the appropriate order. So that tells me this is going to be ground state. And I'm going to say because all of the electrons are in increasing energy levels. And I'm going to put order because I think that makes sense as well. Now, if I wanted to use that information to help me to decide what element this is, I would add up the 2 plus the 2 plus the 6 plus the 2 plus the 6 plus the 1. 2 plus 2 is 4 plus 6 is 10 plus 2 is 12 plus 6 is 18 plus 1 is 19. Element number 19 is potassium. And that covers it. Okay, so that finishes the notes for Unit 5. There's no homework tonight. We will have a work day in class tomorrow. If you have any questions, please let me know.